Okay, so far we have learned to look at the molecular ion peak in the mass spectrum, which tell you the molecular weight of the molecule. Okay, we learned how to use the nitrogen rule to the molecular weight, so it tells you if there's an odd number of nitrogen in the molecule or not. Okay, all right, we're gonna move on to this one, M+2 Peak. We're gonna skip rule 13 to the end. We're gonna learn this one first. Okay, this one tells you the presence of bromine, chlorine, and also add iodine into the mix. Okay, anyway, all right, let's start with isotope. Okay, so isotope is an element that have the same number of proton but different number of neutrons, so it's get heavier. So we have protium, all right, no neutron. Deuterium have one neutron, add one neutron into it, and tritium add two neutrons, so it's get the heaviest hydrogen. Okay, a little bit about tritium. So tritium is an isotope of hydrogen. This guy, we can use it for like a nuclear reaction. And if some of you are a Spider-Man fan like me, and you watch the Tobey Maguire Spider-Man 2 back in the day, okay, we have uh, Dr. Octopus. He was working with the tritium, trying to make a nuclear reaction out of it, and it exploded, and he get crazy up from that. Okay, that's a tritium. Anyway, now we don't really use hydrogen in the mass spectrum, so we're gonna focus on carbon. Okay, so carbon has isotope too. So carbon, we have carbon 12, that's a regular one, the one that we deal with a lot, right? We have carbon 13, carbon 14. So carbon 13, so let's start with carbon 14. So carbon 14 is really small. We don't really do anything with it, okay? But carbon 13 has 1%, okay? If there's 100 atom of carbon, one of them, okay, is carbon 13. And guess what? This carbon 13 shows up in a mass spectrum. Let's take a look. Right there, that's the carbon 13, the species that has carbon 13 in it, okay? And guess what? The relative percent abundance is 1%, 1.1%, right there. Okay, whatever the how many species of this molecular ion peak goes through the detector, 1.1% of that, okay, is carbon 13. All right, let's be familiar. How can you spot this carbon 13, okay, species? Where is it at? Where's an M+1 peak? We call M+1 peak. That's an M, right? What is that? 142. This is 120, 130, 140. That's probably 142. Okay, even though I don't tell you, you should be able to look at the y-axis mass per chart and kind of guess that's an M+ peak. All right, the one right here below, the small one right there, that's an M+1 peak. That's this compound that had one carbon 13. Okay, all right, so this decane 10 carbon. Let's try icosane 20 carbon. Where's M+1 peak? Start with M+ peak first, the molecular ion peak. This one 282, 250, 60, 70, 80. Probably M+ peak, molecular ion peak. The one next to it, can't even see it, real small. That's an M+1. Okay. All right. Actually, in this class, we don't really care about M+1. We're gonna care about M+2, but I have to talk about M+1 first. Okay. So M+2 next to it, right next to the M+1 peak. All right. Why do we care about M+2 peak? Because it tells you the presence of chlorine and bromine. Let's start right here. Chlorine in nature comes in two flavors, okay? Vanilla and chocolate. No, just joking. Chlorine, we have chlorine 35 and chlorine 37, all right? Look at the percent abundance, okay? In nature, they are 75% are chlorine 35 and about 25% are chlorine 37. So the ratio is about 3-to-1 ratio. What does it really mean? So let's say if I have a solution of isopropyl chloride, okay, and in this solution there are 100 molecules of isopropyl chloride. 75% of those, 3-to-1, right? 75% contain chlorine 35 in black, and the other 25 is chlorine 37. Okay, so in red. All right, so percent abundance 75%, 25%. Now, this matters because these two compounds, let me ask you this question, think with me, okay? These two compounds, do they have the same mass? No, they don't have the same mass. What if, just what if, I'll take a sample of this solution, put into mass spec. Do you think that these two will show up in one peak, or they show up in two separate peaks? They're different mass, they're gonna show the two different peaks, right? Separate peaks. Okay. What is the height of those two peaks? gonna be 3-to-1 ratio, 75%, 25%. So we're gonna look right here. So when you have a mass spectrum, this compound contains one chlorine. You're gonna see that. Hey, look at M+ peak and M+2. You're gonna be like, oh, that's 3-to-1 ratio. That's one chlorine. That's how it works. Okay, M and M+2 peak tell you the presence of chlorine and bromine. Okay, I'll take a look at bromine. This one quick. All right, bromine, two isotope, bromine 79 and bromine 81. They are about 1-to-1 ratio, which means that if you have a compound, let's say it contain one bromine, chances are 50% is regular bromine 79. The other 50%, about 50%, 49.5, okay, is M+2 bromine 80, and they show up two separate peaks, like a doublet like that. Okay, it tells you, hey, if you say M+2 peak almost equal in percent relative abundance, it tells you, hey, that's you got one bromine in it. Okay. Lastly, if we have iodine, iodine doesn't have isotope, just iodine 127. Okay, iodine can exist just by itself, iodonium ion, slightly stable, mass per shot of 127. If you don't see anything, no bromine, no chlorine, no 3-to-1 or 1-to-1 ratio, look for chlorine. Look for an iodine. 127 tells you, hey, you got an iodine in it. Okay, so this compound contains an iodine. All right, let's put this into use. Okay, let's do practice number 4 together. All right.